Welcome to Get Your FRQ On. This question is from 2011, Form B, it's question 1, and it is calculator active. In the question stem, we've got a cylindrical can with radius 10 millimeters being used to measure rainfall. The can is initially empty, and rain is entering the can over a period of 60 days. The height of the water in the can is modeled by a function s, where s of t is measured in millimeters and t is measured in days on the closed interval from 0 to 60. The rate at which the height of the water is rising in the can is given by the function s prime of t equals 2 times the sine of 0.03t plus 1.5. In part A of this question, we are asked to find the height of the water at the end of the 60-day period. The height of the water after the 60 days can be found by using the equation s of 60 equals the integral from 0 to 60 of s prime of t dt, which is equal to the integral from 0 to 60 of 2 times the sine of 0.03t plus 1.5 dt. And since this is a calculator active question, we're going to use our calculator to evaluate the integral. S of 60 is the integral from 0 to 60 of s prime of t dt, which is the integral from 0 to 60 of 2 times the sine of 0.03t plus 1.5 dt, and that turns out to be 171.813 millimeters. In part B of this question, we are asked to find the average rate of change in the height of the water over the 60-day period. The average rate of change in the height of the water over the 60-day period can be found by using the formula for average rate of change over the interval from 0 to 60, which is going to give us s of 60 minus s of 0 all over 60 minus 0. Once again, this is a calculator active question, so we're going to use our calculator to find the average rate of change. So s of 60 minus s of 0 over 60 minus 0 is equal to 171.813 minus 0 all over 60, and that turns out to be 2.864 millimeters per day. In part C of this question, we are asked at what rate the volume in the can is changing at time t equals 7. Well, the volume of the can is given by pi times r squared h. So the volume at time t is 100 pi times s of t. So dv dt is 100 pi times s prime of t. So it follows that dv dt at t equals 7 is 100 pi times s prime of 7. Since this is a calculator active question, we'll use our calculator. dv dt at t equals 7 is 100 pi times s prime of 7, which is 602.218 cubic millimeters per day. In part D of this question, we are asked to use the intermediate value theorem on the interval from 0 to 60 to justify why there must exist some time t on the open interval from 0 to 60 where the heights of the two waters are changing at the same rate. So in the original statement of this question, d of t is defined as m prime of t minus s prime of t. So it's important to note that m prime of t and s prime of t are both continuous functions, so their difference is also going to be a continuous function. So this implies that our d of t function is continuous, which is one of the requirements to use the intermediate value theorem. So since we're checking the interval from 0 to 60, let's check d of 0 and d of 60. d of 0 is m prime of 0 minus s prime of 0, which is negative 0.675, and we note that that is negative. d of 60 is m prime of 60 minus s prime of 60, which is 69.377, and we note that that is positive. So d of t being a continuous function, with d of 0 being negative and d of 60 being positive, does imply that there is some time t between 0 and 60, such that d of t equals 0, which implies that m prime of t is equal to s prime of t. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.